Okay, so the equation of the circle C is find the center and the radius. Now, again, if you're provided with it, you compare it directly to the formula on page 19. And then I do a direct comparison with each part. So the 2 is the 2g, and the -4 is the 2f. So g is 1, and f is -2. And sorry, C is -20. So if I'm looking for the center is -g minus f. So that's -1, 2. So -1, 2 is the center. The radius is g squared plus f squared minus c. Again, on page 19 of the table, square g and you get 1, square -2 and you get 4, minus -20, so that's plus 20. So this ends up being 5 as well. So that's your center, that's your radius, and I gave 5 marks to that. Two lines L and K intersect at the point 2, -2. So we have two lines that intersect at 2, -2. One is L, one is K. That's all we know about them for the moment. The distance from the center of circle C, so we're not sure where circle C is. Let's say it's here somewhere. So the distance from the center of circle C to L and K is 2√5. Okay, so actually we could probably draw this a lot better. So it's like they're tangents basically. So it's kind of something like that. So the distance from the center to each line is 2√5. So what we're saying really is the distance there is 2√5. And the distance there would also be 2√5. So find the equations. Now, L and K are lines. So if I ask you to find the equation of any line, I would hope you would always write this down. Okay, that is the equation of any line. Now, do we know anything about this line? Well, we do know that they intersect at 2, -2. So it doesn't matter which line, you're treating it really as one line for the moment. We're kind of writing down the general line. So I'm going to label that X1, Y1 because I know 2, -2 is on L and K. So I'm going to fill that in. So -Y1 is going to be +2. I can't do anything about my slope because I don't know it. And that's what I have for the moment. So we can just tidy up a little bit more. -2m. And I guess we can put it all on the one side. mx -2m. Actually, I might put the y next because usually when we have a line, we have x, y number. So we have mx -y -2m -2. Now, that's what I would call the general equation of the line L or K for that matter, either of them. Now, what else I know is that the distance from that line to the center of the circle is 2√5. So if I use my center, -1, 2, it was -1, 2, yeah. And the distance I know from that point to that line is supposed to be 2√5. So what I'm going to do is I'm going to use my formula that tells me how to get the distance from a point to a line. So I'm just copying this out of my log tables. It is top of page 19. And it's there for a reason because it often connects lines and circles. So it's kind of in between the line formulas and the circle formulas. So my line is this mx business, and I am going to use this as my x1 and y1. So I'm looking for the distance from this center to the line. And of course, I know my answer, which is why I'm doing what I'm doing. So the x is going to be replaced with -1, minus the y is going to be replaced with 2. I can't do anything about the m's. Now, the square root of my a is my m in this case. So in other words, it's the coefficient of x, plus my b is -1. So that's going to be my -1 squared. Now, just to backtrack there, on page 19, maybe I should have pointed it out, but on page 19, it does tell you that you're using this general equation of the line when you're using this formula. So the a is the number with x, b is the number with y. So that is where I'm getting the m, because m is the number with x in this case, and minus 1 technically is the number with y. Now, remember, I know the answer. I know that I can let this equal to 2 root 5. So I'm going to tidy up a little bit. So I end up with minus m minus 2 minus 2m minus 2. Underneath the line, the square root of m squared. Now, minus 1 squared is 1, so that ends up being 1. And I just tidy up that a little bit further. Minus 3m minus 4. Minus 3m minus 4, and that's all over the root of m squared plus 1. And remember, each time it's 2 root 5 here. Now, to get rid of that square, I'm going to square both sides, and I obviously have the modulus bars as well. So we're going to square both sides. So I'm going to square this guy. I'm going to square whatever's underneath. And of course, if I square one side, I have to square the other. So I'm going to square both sides. Now I'm going to just write this out twice, just to be careful that we're not skipping any steps. Now, when I square a square root, I'm just left with m squared plus 1. When I square 2, I get 4. When I square the square root of 5, I get 5. So that's where we're at the moment. Then I get 9m squared. So I'm just multiplying out here. Plus 12m plus 12m plus 16 all over m squared plus 1 is equal to, now that's 20 over 1. Cross multiply 9m squared plus 24m plus 16 is equals to 20m squared plus 20. Now you can see a quadratic forming here, which is good. You know, this is what we want. Minus 24m. So I'm just kind of bringing everything to the one side. Okay, so now that we're at this stage, I can do the minus b formula on that. Now I might just skip that bit to speed things up. So one of my m's is 2 and my other m is 2 over 11. So now that I have my two possible slopes, so in other words, I have a slope of L and I have a slope for K, I can go back now to my, my formula. So remember, each of them passes through to minus 2. So that is in both lines. So when I do my y minus y1, x1, y1, I end up with y plus 2 is equal to, now the slope here, m x minus x1. Y plus 2 is equal to 2x minus 4. Y is equal to 2x minus 6. Now you can arrange that whatever way, but anyway, I've put it that way. And then y minus y1 is equal to m bracket x minus x1. So I'm going to bring the 11 over because it's there in the denominator. That's how we normally deal with fractional slopes. 11y plus 22 is equal to 2x minus 4. Now with this one, I'll probably just bring it all to the one side just because, you know, I'm not going to get x on its own, plus 4. So the kind of neatest version of this really is going to be 26 equals 0. So there's my two equations, L and K.